Hey there, awesome viewers. Welcome back to Fix Flare Tech YouTube channel. I'm MQ Joshi and today, we're diving into the electrifying world of voltage. Now, you might be wondering, what exactly is voltage, and why does it matter? Well, imagine a force that powers everything from your smartphone to the lighting in your home. It's like the driving force behind the scenes. That's voltage. In this video, we're going to unravel the mysteries of voltage, exploring its types, understanding its units, and discovering why it's the powerhouse of electrical systems. But before we dive in, don't forget to hit that subscribe button and ring the notification bell so you never miss out on our electrifying content. Now, let's spark up our knowledge about voltage. What is voltage? Voltage, also known as electric potential difference, electromotive force EMF, electric pressure, or electric tension, is defined as the electric potential difference per unit charge between 2 points in an electric field. Voltage is expressed mathematically, i.e. in formulas, using the symbol V or E. In a static electric field, the work required to move per unit of charge between 2 points is known as voltage. Mathematically, the voltage can be expressed as voltage equals work done W divided by charge Q, where work done is in joules and charge is in coulombs. Thus voltage equals joule divided by coulomb. We can define voltage as the amount of potential energy between 2 points in a circuit. One point has a higher potential and the other points have lower potential. The difference in charge between higher potential and lower potential is called a voltage or potential difference. The voltage or potential difference gives the force to the electrons to flow through the circuit. The higher the voltage, the greater the force, and hence the more electrons flowing through the circuit. Without voltage or potential difference, electrons would move randomly in free space. Voltage is also sometimes referred to as electric tension. For example, the voltage handling capacity of cables such as 1 kV, 11 kV, and 33 kV are referred to as low tension, high tension, and super tension cables respectively. Definition of potential difference as potential of electric field. As mentioned, voltage is defined as the electric potential difference per unit charge between 2 points in an electric field. Let us describe this using equations. Consider 2 points A and B. The potential of point A with respect to point B is defined as the work done in moving a per unit charge from point A to B in the presence of electric field E. Mathematically, this can be expressed as is also a potential difference between points A and B with point B as a reference point. It can also be expressed as. Now voltage can be quite a difficult concept to understand conceptually. So we'll use an analogy to something tangible, something in the real world, to help make voltage easier to understand. Understanding voltage by analogy. The hydraulic analogy is a common analogy used to help explain voltage. In the hydraulic analogy, 1. The voltage or electric potential is equivalent to hydraulic water pressure. 2. Electric current is equivalent to hydraulic water flow rate. 3. Electrical charge is equivalent to a quantity of water. For an electrical conductor is equivalent to a pipe. Analogy 1. Consider a water tank as shown in the below figure. Figure A shows 2 tanks filled with the same water level. So, water cannot flow from one tank to another tank as there is no pressure difference. Now, figure B shows 2 tanks filled with different water levels. Hence there is some pressure difference between these 2 tanks. Thus, water will flow from one tank to another tank till the water level of both tanks becomes equal. Similarly, if we connect 2 batteries through conducting wire with different voltage levels, then charges can flow from the battery of higher potential to the battery of lower potential. Hence, the battery of lower potential gets charged till the potential of both the battery becomes the same. Analogy 2. Consider a water tank placed at a certain height above the ground. There is a hose at the bottom of the tank as shown in the below image. The water pressure at the end of the hose is equivalent to the voltage or potential difference in an electric circuit. The water in the tank is equivalent to the electric charge. Now if we increase the amount of water in the tank, then more pressure is developed at the end of the hose. Conversely, if we drain a certain amount of water from the tank, then the pressure created at the end of the hose will decrease. We can assume this water tank is like a storage battery. When the voltage of the battery decreases, the lamps get dimmer. Analogy 3. Let us understand how work can be done by voltage or potential difference in an electric circuit. A simple analogy between the hydraulic water circuit and the electric circuit is shown in the video. As shown in the hydraulic water circuit, water flows through a pipe driven by a mechanical pump. A pipe is equivalent to conducting wire in an electric circuit. Now, if a mechanical pump produces a pressure difference between 2 points, then pressurized water will be able to do work, such as driving a turbine. Similarly, in an electric circuit, the potential difference of a battery can cause current to flow through the conductor. Hence, work can be done by flowing electric current, such as lighting the lamp. SI unit of voltage. The SI unit for voltage is volts. This is represented by a V. Volt is a derived SI unit of voltage. The Italian physicist Alessandro Volta, 1745–1827, who invented the voltaic pile, which was the first electrical battery. Hence, the unit volt is named in honor of them. Voltage formula. The basic formula for the voltage is shown in the video. Voltage formula 1, Ohm's law. According to Ohm's law, voltage can be expressed as voltage equals current asterisk resistance. V equals I asterisk R. Voltage formula 2, power and current. The power transferred is the product of supply voltage and electric current. P equals V asterisk I. Now, put I equals V slash R in the above equation, we get. Thus, we get voltage equals the power divided by current. Mathematically, V equals P slash I volts. Voltage formula 3, power and resistance. According to equation 1, voltage is the square root of the product of power and resistance. Mathematically, voltage circuit symbol, AC in DC. AC voltage symbol. The symbol for AC, alternating current, voltage is showing in the video. DC voltage symbol. The symbol for DC, direct current, voltage is shown below. Dimensions of voltage. Voltage, V, is a representation of the electric potential energy per unit charge. The dimensions of voltage can be expressed in terms of mass, m, length, L, time, T, and ampere, A, as given by mL squared T caret dash caret 3A caret dash caret 1. How to measure voltage. In an electrical and electronic circuit, a voltage measurement is an essential parameter that needs to be measured. We can measure the voltage between a particular point and the ground or 0-volt line on a circuit. In a three-phase circuit, if we measure the voltage between any of one phase from the three-phase and neutral point, then it is known as line-to-ground voltage. Similarly, if we measure the voltage between any two phases from three-phase, then it is known as line-to-line voltage. There are various instruments used to measure the voltage. Let's discuss each method. 1. Voltmeter method. The voltage between 2 points in a system can be measured by using a voltmeter. To measure a voltmeter must be connected in parallel with the component whose voltage is to be measured. One lead of the voltmeter must be connected to the first point and one to the second point. Note that the voltmeter should never be connected in series. Voltmeter can also be used to measure the voltage drop across any component or the sum of the voltage drop across two or more components within a circuit. The video shows the voltmeter connection for the measurement of voltage across the resistor. An analog voltmeter works by measuring the current through a fixed resistor. Now, according to Ohm's law, the current through the resistor is directly proportional to the voltage or potential difference across the fixed resistor. Thus, we can determine the unknown voltage. Another example of a voltmeter connection for the measurement of voltage across a 9V battery is shown in the video. 2. Multimeter method. In present days, one of the most common methods to measure the voltage is by using a multimeter. The multimeter can be either analog or digital, but digital multimeters are most commonly used because of higher accuracy and low cost. The voltage or potential difference across any equipment can simply be measured by connecting probes of a multimeter across the 2 points where the voltage is to be measured. The measurement of battery voltage by using a multimeter is shown in the video. 3. Potentiometer method. The potentiometer works on the principle of the null balance technique. It measures the voltage by comparison of an unknown voltage with the known reference voltage. The potentiometer circuit for the measurement of voltage is shown in the video. Other instruments like an oscilloscope, an electrostatic voltmeter can also be used to measure the voltage. Difference between voltage and current, voltage versus current. The major difference between voltage and current is that voltage is the potential difference of electrical charges between 2 points in an electric field, whereas the current is the flow of electrical charges from one point to the other point in an electric field. We can simply say that the voltage is the cause of the current to flow, whereas the current is the effect of voltage. The higher the voltage, the more the current to flow between 2 points. Note that if 2 points in a circuit are at the same potential, then current cannot flow between those points. The magnitude of a voltage and current depends on each other, as per Ohm's law. A common voltage supplied by the distribution company to residential consumers are 100 V, single-phase AC in Japan. 120 V, single-phase AC in America. 230 V, single-phase AC in India, Australia. A common voltage supplied by the distribution company to industrial consumers are 200 V, three-phase AC in Japan. 480 V, three-phase AC in America. 415 V, three-phase AC in India. Applications of voltage. Some of the applications of voltage include: one of the most common applications of the voltage is to determine the voltage drop across an electrical device or equipment such as a resistor. The addition of voltage is required to increase the voltage rating. Hence, cells are connected in series to increase voltage rating. Voltage is the basic energy source of every piece of electrical and electronic equipment. From small voltages of 5 V to high voltages, 415 V, are used in various applications. One low voltage is usually used for many electronics equipment and control applications. 2 high voltage is used for testing electrical equipment, electrostatic printing, electrostatic painting, electrostatic coating of material, cosmology study of space, electrostatic precipitator, air pollution control, jet propulsion laboratory, X-ray tubes, high-power amplifier vacuum tubes, mass spectroscopy, dielectric testing, food and beverage testing, electro-spraying and spinning applications, electrophotography, plasma-based application, level sensing, induction heating, flash lamps, sonar. And there you have it, voltage demystified. I hope you enjoyed this electrifying journey into the world of voltage. If you found this video enlightening, give it a thumbs up and share it with your fellow enthusiasts. If you have any questions or if there's a specific topic you'd like us to cover in the future, drop a comment down below. Your feedback powers us up. Thanks for tuning in, and until next time, stay curious, stay connected, and keep those volts flowing. This is MQ Joshi, signing off.